Ever wonder what the future of computing really looks like? I'm not talking about sci-fi movies, but what's actually happening in labs and research papers right now. Well, today, we're going to pull back the curtain and take a peek at the cutting-edge computer science that's building our tomorrow as we speak. All right, let's jump in.
So what are the world's brightest minds building today that will define the world of tomorrow? That's the big question, right? We're going to look at the code, the algorithms, and the huge ideas that are literally moving from a whiteboard into the real world. And trust me, they're set to change, well, pretty much everything.
Okay, so here's our game plan. We're going to take a quick tour through 4 super exciting areas. First, we'll talk about securing our digital world. Then we'll see how AI is tackling some massive real-world problems. After that, we'll dive into this idea of an emerging connected universe. And finally, we'll look at the ultimate goal, building machines that can actually understand us.
All right, first up, securing our digital world. I mean, think about it. As pretty much our entire lives move online, the stakes for protecting our data, our privacy, they've never been higher. So researchers are having to completely rethink how we build trust in this digital society.
Now, what's so cool about this is the total shift in power it represents. Usually we trust a central authority, right? Like a bank. But with blockchain, that trust gets spread out. You have this whole network of independent computers, you might have heard them called miners, all working together to verify every single transaction. It's kind of like having hundreds of accountants all checking each other's homework in real time. It just makes the whole system way more transparent and fundamentally more secure, because there's no single weak spot for an attacker to target.
And believe me, the need for this new kind of security is urgent. We're facing some really nasty threats out there, like ransomware. This is a particularly awful kind of attack where criminals basically take your files hostage, encrypt them, and demand money to get them back. You've got 2 main types: locker ransomware, which locks you out of your whole computer, and crypto ransomware, which scrambles your individual files. And these attacks are hitting everyone, from you and me to critical infrastructure like hospitals. It's a huge problem.
And this slide just nails the core difference. On one side, you've got traditional security. It's like a Jenga tower. It might be tall, but it has single points of failure. You pull out the wrong block and the whole thing can come crashing down. But on the other side, you've got something like blockchain. It's decentralized, distributed. It's more like a strong woven net. Because the data's spread out and checked by everyone, there's no single point to attack. It's a fundamental change in thinking. We're moving from building fragile towers to weaving resilient networks. Okay, let's switch gears. We're moving from defense to offense now. Let's look at how artificial intelligence is being used not just to protect things, but to actively go out and solve some of humanity's most complex and pressing problems.
And when you look at the applications, the sheer scope is just staggering. I mean, seriously, researchers are using AI for everything. They're predicting diseases by looking at patient data, flying drones over farm fields to check on crop health, forecasting air and water quality to help our environment, and even catching fraudulent credit card transactions pretty much the instant they happen. This isn't science fiction. This is AI in action, right now.
And here's where it gets really powerful. Take a look at that number, 95.08%. That's not just some random statistic. That's the accuracy that a specific AI model achieved in predicting heart disease just by looking at patient data. Think about that for a second. That is a level of predictive power that could totally transform preventative medicine. We're talking about catching life-threatening risks before they even become a crisis.
So how in the world do they get to a number that precise? Well, researchers basically hold a bake-off for AI models. As you can see in this table, they throw different types of AI at the same problem to see which one performs the best. And while some models, like logistic regression or decision trees, did pretty well, the random forest classifier was the clear winner. The way it works is kind of like having a huge panel of experts. Each one makes a small decision, and then they all vote to come up with one super accurate final prediction. Pretty clever, right?
All right, next up, we're diving into the emerging connected universe. This is all about the Internet of Things, or IoT. You've probably heard the term, but the idea is simple. We're embedding tiny sensors and internet connections into all sorts of everyday objects, cars, shoes, you name it. The goal is to weave a digital layer into our physical world, creating an environment that's truly smart and responsive.
And here is a perfect, really human example of what that means. This diagram shows a wearable device designed for a child. Now, it's not just a GPS tracker. It's actively sensing for things that might be wrong, like a sudden fall, a collision, or even a weird spike in their heartbeat. And if it detects anything, bam, it sends an alert straight to a parent's phone. That's IoT delivering real peace of mind.
And this same idea can be scaled up to do amazing things. Take this smart greenhouse, for example. It's a simple 3-step loop.
First, solar-powered sensors are out there sensing the climate conditions in real time. Then, an AI brain analyzes all that data, comparing it to what the plants need to thrive. And finally, the system acts. It might automatically adjust the water, the light, or the ventilation, all without a human having to lift a finger. It's a perfect, self-regulating system, all thanks to IoT.
And the applications for this are just popping up everywhere you look. Researchers are designing sensors that go right into a soldier's shoe, monitoring their vital signs and location, and get this, they're powered just by the act of walking. They're building smarter cars with in-vehicle sensors that can alert you to speed limits or help you keep a safe distance from the car ahead. And on a bigger scale, they're using data from traffic cameras not just to watch cars, but to actively manage traffic flow and make our cities safer and less congested.
Okay, for our final stop, we're heading to what might be the most ambitious frontier of all, teaching computers to actually understand us. This is the world of natural language processing, or NLP, and it's all about closing that massive communication gap between humans and machines, teaching computers to understand our language not as a bunch of ones and zeros, but the way we do.
You see, the goal here has really changed. It's not just about getting a computer to follow a command anymore. The real cutting-edge research is about understanding context. Can a machine read thousands of lines of programming code and then write a simple, human-readable summary? Can it look at a product review online and detect not just good or bad, but nuanced emotions like joy, disappointment, or frustration? That's where we're headed.
This comparison really says it all. The old way, to get info from a database, you had to speak the computer's language. You needed the right keywords, the right syntax, employees, salary, max. But with natural language processing, you just ask. You can type a question just like you'd ask another person. Show me the employee with the highest salary. The machine gets your intent, and it gives you a straight answer. It's a total game changer.
And this isn't just about spotting keywords like happy or sad. As this little quote from a research paper shows, teaching a machine to understand emotion is incredibly complicated. It involves something called deep neural network models. The best way to think about these is like digital brains with many, many layers. Those layers allow the machine to analyze all the subtle context and hidden meanings in our language, to figure out not just the words we're saying, but the feelings behind them.
So, when you put it all together, from secure, decentralized networks and AI that can literally save lives, to a world where everything is connected and machines can understand our feelings, this isn't some far-off, distant future. This stuff is being built right now, in labs all over the world. So the real question isn't if this technology is coming, it's here. The question is, what kind of world do we want to build with it? Are we ready?